This is Dr. Johnson, and this is part 2 of section 6.1. So we talked about conditional proportions, and now we you're supposed to calculate the conditional proportions for these two situations, A and B. So that's just a simple for number 9 here. It's just using your calculator. So that shouldn't be too hard. So then next, the worksheet talks about a segmented bar graph and a mosaic plot, which you should remember from the reading. So a mosaic plot is just a segmented bar graph that's been widened to also show a second variable of how much of the row total or column total that you want to express as well. So for number 10, fill in a segmented bar graph or mosaic plot. There's an empty one there for you. I don't really care exactly how you do this. You can do it paper and pencil and then take a picture on your phone and put it into your homework, or you can use a spreadsheet to make. Most spreadsheets don't do mosaic plots, but they do segmented bar graphs. So you can use a spreadsheet and then take a clip of it, and then however you get it done. Just there's plenty of ways to do it. So for number 10, find a way to make a segmented bar graph or a mosaic plot. Okay. Then, once you've looked at that mosaic plot or that segmented bar graph, number 11 says, do the conditional proportions and graph appear to provide evidence that at least one patient was more likely to die on a Gilbert shift than on a non-Gilbert shift? In other words, does there appear to be a tendency for Gilbert shifts to have at least one death more often than non-Gilbert shifts? Explain. So the fact that there's the word explain means there should be more than one sentence here. Maybe you can fit it into one long run-on sentence, but it's make sure you're using a complete sentences when you answer this question, and maybe one sentence. It depends on how well you can kind of explain things succinctly, but look at the bar graph, and you should get a good intuitive feel for what's different there. Okay, so number 12, without doing any further analysis, so we're not doing any more math, just looking at the bar graph or the mosaic plot, do you consider the difference between the conditional proportions to be striking, worth reporting to a jury? So that's a intuitive question. So I tried not to grade intuitive questions too harshly. So just give us your thinking there. Number 13. This is again another reason why stats is more of a wisdom class that uses math. In this way, you're making an intuitive wisdom judgment, and you're using numbers, and in this case bar graphs and mosaics that are pictures to help you see the numbers better. But it comes down to making common sense decisions. Now, number 14, calculate the difference in conditional proportions of death between Gilbert and non-Gilbert shifts. So for 14, you're going to want to do when you do a difference between this and that, it usually means these ones minus these ones. Okay. Does the value of this difference strike you as noteworthy? So then, again, that's a complete sentence we're looking for there. Now calculate a different statistic, the ratio of conditional proportions of death between Gilbert and non-Gilbert shifts. This ratio is called a relative risk. So you can calculate it and then write a sentence interpreting the ratio value, as the prosecution might present to a jury. Does the value of this ratio strike you as noteworthy? So again, think of this as imagine you're trying to prosecute this nurse, and you want to use this number. What does the number mean? How did it come about? How could you use it in a sentence that a jury would understand it? Okay. Now here's a definition that can help you a little bit while you answer that. Relative risk is the ratio of two conditional proportions. So ratio is divided, so one divided by the other. It indicates how many times greater the risk of an outcome is for one group compared to another. So number 16, even if the difference between these two conditional proportions of death is found to be highly statistically significant, can we absolutely conclude from this analysis that Kristen Gilbert was responsible for, i.e. caused, the increased chance of death on her shifts? Explain your answer. So for this one, the key word there is absolutely. Can we absolutely do this? And that harkens back to what we talked about in Chapter 5. So this is a review of Chapter 5 question. Okay, suggest an alternative explanation that the defense attorneys might use to explain the large difference in death proportions between the two groups. Okay, so now you gotta switch your perspective. Imagine you're defending Kristen Gilbert, and these numbers do show a difference, but then try to come up with a potential another confounding variable, another explanation. Like maybe she wasn't killed, maybe they're different because of, come up with something. Okay, use your common sense knowledge of the world. Okay, now suppose the data had turned out as shown here. So now we've got different data there. Okay, so then now with that different data, calculate the conditional proportions of death for Gilbert shifts and for non-Gilbert shifts. Calculate the difference in these conditional proportions. How does this difference compare to the one in question 14? Are they similar? Calculate the relative risk. How does this ratio compare to the one in question 15? Are they similar? For which table of data, this new one, or the original actual data, would you consider the evidence against Gilbert to be more persuasive or incriminating? Explain. So again, for part D there, that should be full sentence or two. Explain why one of them is more incriminating than the other. Okay, so now for 19, produce a hypothetical 2x2 table with the same marginal totals, but with the property that the data reveal virtually no association between the variables. In other words, produce a table so the conditional proportions are very similar between the two groups. So there's a couple ways to do this one. One is to, you can kind of do some algebra. So you can do this with algebra if you are familiar with doing algebra. Like make one of these numbers, make like this number x, and then you can figure out what the other ones are using algebra. Now, if you like to avoid algebra, or if the idea of doing algebra scares you, you're not supposed to know algebra in order to do this class. This is a stats course. And so another way to do it would be to put these into a spreadsheet and then guess and check. Let me show you how to do that. So let's see, I'll start a new spreadsheet, and then let's do a zoomed in thing, and then let's see, I've got kind of make a Gilbert and not Gilbert, kind of shorter names here. Someone died, and no one died. Okay, and then you've got kind of a total, and then I might need to make these work. So, oh, I spelled total wrong. How embarrassing. Okay. Now, fill in the numbers we know. 257, 1384, 1641, and 457, and 1184. Let's make that smaller so it all fits in there. Okay. Then make this just a guess number for right now. Like I'm going to pick a dumb guess, like 100. Now we know that these numbers have to add up to the total. So for spreadsheets, if you start off with the equals, then you can do a formula. You can do and then it's suggesting a formula, which is the correct one. But you can also you can either type in B4 because I want to use cell B4, or I could click on it. So I could click on total, then I'm going to press the minus, then I'm going to click on this one. And then I'm going to click here, and I'm going to click this equals this, so click on that, the total, minus this. And then this needs to equal this total minus this. Okay. Now, however, I think in this case, then I can then do proportions now. So if I do Gilbert, non-Gilbert, and then patient died, and nobody died, then I can do this is, I'm going to do the same proportions, conditional proportions that we did earlier. So we do here, we do the conditional proportion just like we did last time, but with our different numbers. So this is equal to this number divided by this number. And this is equal to this number divided by this number. And then those are going to be the same for the other row. So I can just drag it over. Okay, now I've got it all set up so that now it's showing too many decimals. Let's try to make it simpler. There we go. All right, so now so I want to guess and check. I want these numbers to be the same and these numbers to be the same. So like 100 might be too high. What about 90? Still not enough, but if I go down to 50, I've gone too far. So it's up to you guys. Guess and check until you get there. All right? And then what would the segmented bar graph look like for the 2x2 table with virtually no association? So once you've found those numbers, go ahead and make the segmented bar graph for it. And that completes section 6.1.